This is geometry, working on the review A. We're going to find an image of 3 comma negative 8 using this translation rule. So this is our x value and our y value. We'll plug it in. So to find c prime, I'm going to take 3 minus my rule and negative 8 plus the 6, which is the rule. So my c prime is going to be 0, negative 2. So I'm using the rule to help me translate my original point to find my image. Now if I have a image and I'm looking for the original shape or the pre-image, I've got to work backwards. So that means I'm going to take my rule, and that rule is supposed to produce this negative 5. So by adding 3, I see I get negative 2. And by taking my rule and equaling it to 12, my y value, I'm going to get 6. So my original G point, not G prime for sure, and not G double prime either, it's the original point, the pre-image, which is going to be G, is negative 2 comma 6. So now we're going to do some reflections. We have some rules right here that talk about the reflection rules. Reflection over the x-axis is where the y value changes. Reflection over the y-axis is where the x value changes. And then we have rules for flipping over y equals x, which is a positive line, and y equals negative x, which is a negative line. Negative slope line. So we're going to try to reflect this over y equals negative x. You can do this a couple different ways. We can think about it as an xy axis reflecting over the line y equals x. We have the point that's 12 over, 9 down. I need to count how far down to that line I need to go and how far past it would be the same amount. So that's where I need to be. But without it on a grid, I can't count accurately. I don't know where I'm at, so we can use the rule. The rule for reflecting over y equals negative x is negative y, negative x. So if my point is 12, negative 9, then p prime, I'm going to switch them. Negative 9, positive 12. So I switch the order of my original point, then I change the signs. So I get positive 9, negative 12. Positive 9, negative 12. And that seems reasonable. So now to reflect over the line, y equals negative 7. Well, if I'm down here at 12, negative 9, and I'm going to reflect over this line y equals negative 7, I have to come up to get to that line and then further past it to figure out where my rotation is. So that's 2 units to get to that line and 2 units to get past it. So I'm going to go from negative 9 to negative 7 and negative 7 to negative 5. So my p prime is going to be 12, negative 5. Reflecting over the x-axis. Here's your x-axis. We have our point of 12, negative 9. Now if you were on a grid, or you could count up 9 spots to get to here, then I need to go 9 spots to get past it. So the answer has to be 12, 9. The other way to do it is to think about the rule, which is reflecting it over the x-axis. That's x comma y. the x stays the same, but the y is changing. When you reflect over the x-axis, the x stays the same, but the y value changes. So we're going to change the y. So in this case, p prime is going to be 12, 9. And that's what I would have. I would have been over 12 and up 9. Here's a point. T is -3, -9. I'm going to rotate it 90 degrees. Now, what we've talked about before is trying to rotate our paper. That can be really helpful if you're on a grid. If we're not on a grid and we just have coordinates, maybe it would help you best if you just use the rule. So we have the rule, x, y. We need to change their order and change the sign in front. So to get t prime, which is a 90-degree rotation, I'm going to change the order. And then I'm going to change the sign in front. So it's a +9, comma, -3. 180 degrees. X, y. That's going to become -x, y. So my signs are going to change. So I'm going to keep them in the same order, but change the sign. So 3, 9. 270 degrees. We switch the order, so y then x, and put the negative on the right side. 90 degrees was the negative on the left side. 270 degrees is the 90 on the right side. So t prime is going to switch the order. So it's -9, -3, but I changed the sign on my second value. So that ends up becoming a +3, -9, 3. Here we have a rotation. We have a figure, and we have to figure out which A, B, or C is going to represent a rotation. Well, if I use a piece of tracing paper, just to give you a visual, and we were to rotate it, and I rotated it around, notice that I look a lot like A, but the dot's on the wrong side. So it's not A. B is more like a translation, a slide over and down. So if this was my original point, I think I'm going to create that figure. So the long side's on the right, the dot's on the lower part of the bubble. So my answer is C. A reflection. If I trace this out, we can try a reflection. So if I were to slide it over and down, that looks like B. It looks like the same exact shape. If I flip it down, you can kind of still see it there. I'm pointing to the right with my dot in the lower corner. That's not like this. But if I flip it sideways, it looks exactly like that one. So this is a reflection. This one looks more like a rotation. This is a translation. And this was a reflection. Number 11. If I trace out 11, And you might not have the tracing paper, and you're not really supposed to. You don't have to have it, but it's just giving you the visual of what we're thinking about. If I translate it, I should have that same exact shape again. So that's over and up, gives me the same shape, so that's a translation. Where this becomes a nope, that's not even a rotation. Almost was. Okay, that's probably a reflection. B's a reflection. And it looks like A is a rotation. So we're looking for a translation though, so that's going to be C. Here's another reflection. We can reflect it over, so the shape is going to look like this. I don't have that shape anywhere. Or we can reflect it that way, where the shape is going to look more like that. And that's this one, that's A. What would be the new position of this point if we reflect it over the line y equals 1? Well, this is a lot harder if you're not on graph paper. So you got to be a thinker. We're at 9, -4. And if I'm going to reflect over the line x equals 1, if it's 9 units to get even with this, then it's only going to be 8 to get here. Then I need to go 8 more that way. So from the 1 spot, moving 8 to the left is going to be -7. I'm going to be -7, and I'm still going to be down here at -4. So that has to be C. What would be the new position of the given point (1 over 9 down) after we rotate it 90 degrees? Well, let's see if we can make some sense of this. This is what you need to visually be thinking. You can turn your paper and have an idea. Tracing paper kind of makes it fun. So I'm going to rotate the paper 90 degrees. So what was my positive x becomes my positive y. And now I'm over here in this first quadrant. What used to be -9 going down is now +9 for the x. And what used to be +1 for the x is now +1 for the y. It's in the same position, it's just switching the letters and changing the sign on the front. So +9, +1. You can just turn your paper and you can see that same idea. What used to be 1 to the right is now 1 up. What used to be 9 down is now 9 over. What would be the new position of this given point after a reflection across the x-axis? Well, we have a rule for the x-axis. A comma b is going to turn into the x-axis, that's up and down, those are the y values changing. Okay, I don't memorize these, I think about them and I recognize what's happening. So all I need to do is change, so we're going to do -2, 3. That's taking your point and changing the second sign. What would be the new position of the given point after the translation? We're going to move this 2 units left, so we take 2 off of that, so 7 minus 2, and then we move it 4 units up, so 4 plus 4, That's going to give me 5, 8. There's my A. Here we have our original shape because it doesn't have primes on it. Here's the primes. So if I trace that out and I put my pencil on the origin, when I rotate my paper, when I rotate it, it changes what quadrant you're in. It moves it over. And you can see that 90 degrees is how we're getting over to this image. When we do a rotation, we're not talking about a rotation right on the figure. So it's not a rotation in a slide. We do all of our rotations from the origin. So it's got to pivot from the origin, and that's what moves it to the different quadrant. Just a 90 degrees. So this is a 90-degree rotation. Counterclockwise. And the rule for that is A comma B. All the values that were negative x's are now going to become negative y's. All the values that were negative y's are now going to become positive x's. So we're switching the order and changing the sign on the left. That's the rule for a 90-degree rotation. Here, we can trace out our image. Here we have our pre-image, or our original. So you've got to think about, does this look like it's some sort of rotation? Does it look like some sort of reflection where we're flipping it? Or does it look just merely a slide? This is a translation. It looks like D is going 1, 2, 3, 4, 5 to the left, and 1, 2, 3 up. From D to get to D prime, 1, 2, 3, 4, 5, 1, 2, 3. So we're going 5 units left, 3 units up. The rule for that is we are subtracting 5, so we can go 5 left, and we're adding 3 to every spot. Even the E, 1, 2, 3, 4, 5, 1, 2, 3. Even the F, 1, 2, 3, 4, 5, 1, 2, 3. And the G and the H. A dilation. We actually haven't learned the dilations yet, but one thing you can look at, if we have figure B and figure A, determine the scale factor. We're going to work from A to B. From A to B, if you take a count, 1, 2, 3, 4, that's a point that corresponds with this one. So if A is the original and B is the image, it doesn't say which way we're going, and that would matter. Scale factor is always image over original. So the image, if A is the original and B is the image, it takes 5 to get there for for the original shape, it took 10, and that reduces. So the scale factor would be 1/2. We haven't learned that yet, perhaps, in this class, or we have, all depending on which year you're listening to this. Here we have the same idea. So you just find a point. It really helps. You can also take a length of a side. This length of the side is 1, 2, 3. The length of this side is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the image goes first. That's 3. The original goes second. Image over original is your scale factor. So that becomes, the scale factor is 1/3. You could count your distances if you wanted. Image is 2, original is 1, 2, 3, 4, 5, 6. So that's 2/6, and that reduces to 1/3. Okay, last couple. We're going to take our figure here, and we're going to rotate it, and you see that it falls right on the shape. So the 3x minus 6, which is right here, is becoming the 12. So 3x, I said minus 6 maybe, 3x plus 6 is equaling 12. Now we have to minus the 6 and divide by the 3, and that gives us an x value of 2. And if we look at the g, this guy's g right there, and we rotate it, g is going to be 43. There's no formula we need to write for that one. Last one. If I come in here, this is what you're trying to visualize. If you don't have the tracing paper, which you wouldn't have on the test most likely, you would swing. And what used to be the small part here is now becoming the small part up at the top. So the 8 is equaling the y. And this bottom portion, x plus 14, is equaling the side portion, which is 3x plus 2. X plus 14 is equaling 3x plus 2. Now it's an algebra problem. We have an equal sign, so we're going to go to opposite sides of the equal sign. I see that 3x is larger, so I'm going to bring the 1x over to the 3x. 3x minus 1x gives me 2x. Then I subtract 2 to move that to the other side, and I have 12. So I just have the 12 on one side, I just have the 2x's on the other. We divide by 2, and x equals 6. There you have it. Good luck.